The natural number e has its own special log, the natural log. All right, let's take a look at e really quick. Here we go. Yes. All right. If you have your calculator ready to go, go to y equals. Ooh. Yeah. Once it looks like here we go. Parentheses. 1 plus parentheses 1 divided by x double close parentheses to the x power. 1 plus parentheses 1 divided by x close parentheses twice to the x. Right. That is the calculation for E. That's the formula for E. Here's the deal. When you hit second table, well, I think you did. Yeah, the graph. No, I'm glad you said something. All right, I'll show you the graph in a second. Here we go. On the table. So let's say at, because I think I had -2 here, right? Yeah. Don't die. No dying. No dying. All right. So at -2, it was 4. At -1, it does not exist. Same thing at 0, it does not exist. When you go to 1, you got 2. When you got 2, you got 2.25. Right? As you get bigger and bigger, notice the e's like kind of stick at 2. But then the number, the decimal places just keep growing and growing and growing, right? So if you want to hit table set, pick a number between, I don't know, 1 and 100. Okay, bigger. How about 50 and 100? 85. Okay, let's say we get to 85. So to start at 85, go back to the table. At 85, E, this is going to be 2.7025. So 2.0725. Yeah, 7025. How do you search for a number? I don't know. So here you go. Hit second table. I do have that. Yeah. Second window. I'm sorry. Second window. And then you can do table set. So, like if you do e to the 1,000. Do e to the 1,000. Not e to. I mean, sorry. Go to 1,000. I should say. Ah! Nice. Oops. 2, 3. Gosh darn it. Enter. 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 Oh, yeah. Second. Hello? Hello? Man. Alright. Anyway, if you go to e to 1,000, let me get rid of this because this is ridiculous. Here we go. Here, go away. There you go. Alright. If you go to e to 1,000, 2, 3, you would get something in the vicinity of 2.7169. Yeah? Right? If you go like, if you type in 85 for the x, then you would get 2.7025 or something. Right? Yeah. So the bigger the number goes, the closer and closer it gets to e. In other words, I'm going to put that up for a reason. If you take, oh yeah, here we go. All right. So if you take, I have no idea. All right. If you take the limit as n goes to infinity of this function, 1 plus 1 over n to the n, it gets closer and closer to the actual number e. Right? So only putting like 1z, 2z numbers is not going to give you e. But as the number n gets bigger and bigger, it gets closer to e, what e actually is. And for some of you, you already know what it is, right? Second quit, it's 2 point something, right? Yeah. Here we go. On your calculator, see where it says ln? If you hit second ln, it gives e. And if you just want e, then it's e to the first power. E is 2 point is a second division sign? Yeah. Oh, thank you. There's E right there, second division sign. You're so smart. So smart. Yeah. It's 2.718281828 something something dark side something something. Yeah. The limit? Very good. Yeah, limits. Yes. Right? So the bigger that number gets, the closer it gets to E. I wrote that notation down because that is a very IBSL HL thing that you will see. It's called limits, all right? You can get there. Right? Yeah. So as the number gets bigger and bigger, it gets close to E, which is like 2.712 da 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 da. That's infinity. It's infinity. Yeah. Which one? Limit. L-I-M. Limit. Yes. When you start doing some calculus, you will be doing limits. It's like, hi. She got it. It's okay. No judge. All right, here we go. Some properties of the natural log, and it's the natural number. So, for example, natural log of 1, right, just means that E to some number is equal to 1. So that means the answer is 0, because E to the 0 power is 1. Right? And B, to rewrite this, is E to what power would give you 0? What's that? Does that exist? Yeah. Right? Natural log of E. 1. Yeah. Because this would be E to what number would give you E? Well, the answer has to be 1. Yeah? And E to what number would get you a negative number? Nothing. Does not exist. Yeah. E to the first power. So you're solving for this. Like, what power would give you E? So that's 1. Right? Yeah. All right, so it's the same thing as logs, right? In logs, you're working with base 10, right? Natural log is base E. All right, the whole point of this was that it's the same, so it's going to be the same properties as logs. We should know that right now, right? Okay, put a star next to that 4th box, the change of base formula. All right, this is going to be the most useful formula for today. All right. Here we go. GDC stands for Graphing Display Calculator. If it's a paper 2, you'll be using a GDC. If paper 1, no GDC. It's no big deal. Right. Here we go. Let's pretend this is paper 2, and you get an answer of log 7. And they want the closest decimal approximation. All right. So you hit log 7. Enter. 8. Yeah, 0.845-ish, right? So that would be an answer you would see in paper 2. Yay. Okay, the next one says log 420. Right. Here's the deal. You want to do it? You can. Oh, no, don't. Here we go. That was my French for no. All right, here we go. Don't give it away. No. Here we go. This is my moment. All right. Let's say you have the log of a base gives you the answer. True? We know that, right? The change of base formula says that you can just take the log of the answer divided by the log of the base, given that both logs are base 10. B on the bottom, B on the bottom, B on the bottom. Right, base is on the bottom. So, guess that. Yeah, so log base answer, right? So it goes log answer divided by log base. That's the formula for change of base. That's it. Okay? Woo! All right, so this thing, all right, is equal to log of 20 divided by log of 4. That is not log 5. Okay? Right? You don't just divide the 20 and the 4. That is not log 5. This is done. this will be a paper 1 answer. Okay? Or if it's paper 2, then you literally go log 20. Oh, nope. Log. Nope. Log. Oh, there it is. Delete. There we go. Log 20 divided by log 4. I hope that did it right. Did it do it? 2.16? Yeah. Hey. 2.16. Now, I know some of you still think that's log 5. Type in log 5. It's not log 5!
But why can't we use this thing?
Fine, if you know how to do it, fine, whatever. Okay, whatever.
I mean, right?
Oh! Oh, see, you do like this, Craigie. All right. All right. That is a paper 2 answer, yay? Okay, here we go. Ignore that entire back page because we did that already. Yay? All right. The assignment on that page, right? When you look at the red sheet, this is the page 241 it is talking about, and your assignment on that will be 1 through 77 odds. So go ahead and write that at the top of that sheet. Okay, on the back of this thing right here. 1 through 77 odds. Yeah. Okay, so that's part 1 of your assignments. Joy. All right. Take a look at your playing cards. We're going to do the flex shuffle. Here we go. Yes. Yes. All right. Here we go. Hearts will be sitting in the back area. Spades and clubs. Hearts, spades, and clubs. Take your stuff, move to another side of the room. Go. Oh boy. Let me see your card. What's that? Yeah, you can leave your backpack. It's no big deal. All right. Part 2 from a different point of view. Yeah, it's actually solving logs. It's no big deal. All right. For those who took math analysis, yay, we should. This is review. If you didn't, it's okay. You'll be caught up today. Here we go. 3 to the x is 9. X is... Nothing? All right. Here we go. For 1 over 25, remember that if it's on the bottom, we had an issue with this on the test a little bit. It's 125 to the negative 1. Truth?
Yeah.
Okay. Which 125 is 5 to the 3rd power to the negative 1.
Oh.
Therefore, x is negative 3. So that's how you solve that. Yeah. It's okay. I mean, okay, so here's the deal. A fraction, if a number is at the denominator, then the exponent is negative. In this case, it's negative 1, because it's just 125 on the bottom, right? And then 125 is has a base of 5. 125 is 5 to the 3rd power. And then power to the power just says multiply those exponents together to solve for 1x. True? All right. No matter how hard you work on your calculator, you will probably not find a nice, pretty number that takes 4 to 17. Heavens no. Heavens no. All right. So here's what you do. Log both sides. Okay? So when it comes to an expression like this, you just log both sides. So you go log 4x is equal to log 17. Log both sides. I love me some log math. This is awesome. I love it so much. Okay. Okay. Here we go. Now what? Drop the x. Exactly. So it goes x log 4 equals log 7. P.S. Could you have used natural log 17? Could you have used natural log? Absolutely. right? If you just write ln all the time, right? I'm going to use base 10. Use base 10. How do you get x by itself? Divide by log 4, because log 4 is number. All right, so x is equal to log 7 divided by log 417. All right, if this was paper 1, that's where you stop. If it was paper 2, you type it into your calculator. It's disgusting. 2.04. Right? This will be paper 2. Right here. I mean, it's nice. It's nice. It's rounded. It's rounded. Right. Yeah, huh? I'm just letting you know, like, what's acceptable for the IB exam. Okay? Okay. Just love. Uh-huh. Log. Yeah. But then you would have to use the change of base formula and do log 17 over log 4. Yeah. Absolutely. All right. Here you go. What is this? It's okay. Repeat after me. Log both sides. That's true. You want to do natural log? Yeah, let's do it. Let's do it. No, I'm not doing a base 5. It's either natural log or base 10. Come on. You want log or natural log? I mean, I'm just saying natural log is shorter to write. Let me show you. Log 5x minus 3, is equal to log 137. I just like dropping ones all day. Right. You could have used log. Natural log works too. You just change in your base. That's all they do. All right, here we go. Talk to me. Drop. X minus 3 log 5 is equal to log 137. X minus 3 is natural log 137 divided by log 5. Add that 3. So x is equal to natural log 137 divided by natural log 5 plus 3. Paper 1. Yay. Paper 2. Type it in your calculator. Yeah. Here you go. 6.057. Is that right? Okay. So 6.057, paper 1, paper 2. Either one of these answers will work. What's up? Yeah. Yes. Yes, it's the same thing. You're just changing the base, and it doesn't matter because it's the same. It still gives you the exponent. The natural log and the log still mean exponent. Yes. Yeah? Okay, here we go. Quick question? We good? All right. What if there was 1 on each side? No, don't just give up. Alante. Log or natural log? What do you want to do? See? Because it's shorter to write. Silly Brian. Seriously. You are so used to your base 10. Oh goodness. Droppity? Yes. Okay. Delete that. Try again, Bucky. Here we go. All right. Natural log 7. X plus 2. Natural log 3. Okay.
No,
all right.
Everything at once. Divide x plus 2 to get that onto the other side. And divide that by log 7.
Was it this class? Yes, it was. Yes, it was. All right. Do you remember when we were doing like finding the inverse, right? And then you had like x plus something over x plus something, right? The trick was to get all the x's to one side or the y's to one side and then GCF. It's the same thing. So you do need to distribute first, right? So you go 2x log 7 plus log 7, because 1 times log 7 is log 7. Right. Okay. Is equal to x log 3 plus 2 log 3. Okay? All right. Group the x's to one side, and anything without an x goes on to the other side. Yay. So 2x log 7 minus x log 3. Truth? Okay. And then the 2 log, 2 log 3 minus log 7. Truth. GCF. GCF. On this side, the GCF is x. So 2 log 7 minus log 3 equals 2 log 3 minus log 7. Divide! Get the x by itself. So, paper 1 says x is equal to 2 log 3 minus log 7 divided by 2 log 7 minus log 3. Everyone say, Alante, you're a genius. No, because he picked ln instead of log. My hand would have been falling off by now if I did log. Alright, that's paper 1. Alright, here we go. Calculator.
Hey.
Right. Stick it in your calculator. Oh, lots of parentheses. Or if you do alpha y equals, you can make it into a fraction. Oh my god. Would you like some cheese with that wine? Ah!
Wait.
No, he eats cheese.
What is this?
Mozzarella. One. You get one.
Hey.
Asiago? Nope.
Wait, I have to get this.
You do. Say it when you got it.
2ln 7
What is it?
minus
So, 0.9? 0.09?
.0.
I mean, but 0.899 would just be 0.09? Yeah. Right. Yep, paper 2. Isn't that the truth?
I got it.
Is it? Okay.
What
What? Oh gosh. Oh gosh. Okay. Woo! Woo! What?
Wait, if it's
We can use them to solve quadratic equations. Get out. Get out. Really? Okay. Okay. All right. Channel your inner Craig. You've all done to the 4th power. Come on. I know because I see you. All right. To the 4th power. The trick is the middle one, e to the 2x, right? So that means the first one has to be e to the 2x and the other one has to be e to the 2x. Has to. Not true. Not true. True. Negative 18 to get negative 3. minus 6 and then positive 3. Hey. 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 Come on. Come on. Hey, it's factoring. It's factoring.
No.
What? Here we go.
Yeah, what do we do?
There's 2 zeros. There's 2 zeros. E to the 2x minus 6 is a 0, and e to the 2x plus 3 is equal to 0. Comment down it. It's going to be okay. All right. Here we go. What was the fast one? As a 6. As a 6. E to the 2x is equal to 6.
Yes.
Cheaper Seth giving away the answers. Here we go. Exponential equation. Log 'em. Exactly. And since we're in E, let's use natural log because you know it's easier. All right. You're just mean. Here we go. No, it's base E. So you remove it. Got it. Wow. All right, here we go. 2x is the natural log of 6. So x is... Oh yeah, ln e canceled. If you drop the 2x on the bottom, it would just be 2x. Right.
I get it.
Which is not the natural log of 3. Truth? Okay. Okay. True. Because I'm just thinking, and I'm not really, but I'm thinking. All right. Right. 0.896. 0.896 or 0.895. Okay. Alright. Seth already figured out the other one because he's, Seth. Here we go. E to the 2x is equal to a negative 3? Here we go. Even if you try to log both sides.
That's more work. Yeah, now we're going more work.
Comment down it, Seth. Here we go. 2x is equal to the natural log of negative 3. Try typing in the natural log of negative 3 in your calculator.
It's gonna yell at you.
It is? At least it's not a Samsung Galaxy.
It's all
Don't blow up.
caps. That's actually a no.
What is it?
It's not a-
Thank you. You cannot take...
There was no such thing as take from LOL.
I saw a YouTube thumbnail that said
Oh, Lord.
real.
I feel...
I didn't watch it. Well, it said they were real.
I feel like you're being irrational. All right. Here we go. You can. You can. All right. C. The paper that is attached to these notes. The paper that says those notes are 23 to 49 odd. So here's the deal. You can combine this into one assignment. Make sure you separate them, though. Do it on a separate sheet of paper. I do not need the copy back. Just do your work on a separate sheet of paper and turn that into me. Now, how will you do your work? You will do your work in groups of 3. Take a look at your playing cards one more time. You will get with the same folks that have the same numbers. So all the queens get together, all the 6 get together, so on. When you get together, put the 3 desks together, and the heart of the group will collect the cards. Okay. Go!
Who's 5?
No!
No!